Hi, um, welcome to my channel. Today I will go over the 7 fundamental physical quantities or the SI system of units according to the IB program and many different curriculum physics curriculums in different systems as well. So the first quantity is basically the length, right? Which is like it can be any distance, can represent distance between 2 points, change in position, for example, wavelength, for example, any length, and the unit is meter, and the symbol is basically small m. So small m is the symbol of meter. But sometimes in the questions or in the problem, you may see a prefix before the small m. So for example, let's say HM. Okay, what is HM? Now, HM means hectometer. So hectometer is not SI system. Meter is SI system. So what I need to do, I need to replace this prefix with its equivalent value. So for example, hecto is 10 to the power of 2. Right? So let's say this is 1 hectometer. So this is 1 times 10 to the power of 2 meters, or basically 100 meters. So 1 hecto is 100 meters. Okay. Another example of a prefix, of course, more common, more popular than hecto, which is kilometer or kilo. So kilo is 10 to the power of 3. So 1 kilometer is 1 times 10 to the power of 3 meters. Right? Another one, let's say mega. So mega is going to be big M. So the big M, the prefix is a big M. It means mega, and that's why I insist to. I'm just showing. The small m is just meter, but big M is mega. So if I see, for example, big M, before as a prefix before a small m, this is megameter. So 1 megameter is 1 times 10 to the power of 6 meters, and so on. And this is actually kind of larger units than meters. But let's say, for example, talk about smaller units than meter. So let's say centimeter. So cm. So centi is 10 to the power of -2, or 1 over 100 meters, right? 1 milli. So mm. So the m here is going to be millimeter. Is 10 to the power of -3 meters, right? Micro mu. So this is a Greek letter, micrometer. So micro 10 to the power of -6 meters, and so on. Okay. So in the system, like Système International d'Unité, this is basically the idea to unify, to speak the same language when I talk about physics, all over the world, worldwide. Okay. So the first physical quantity is length. The unit is meter. The symbol is small m. Now, next, mass, physical quantity, unit is kilogram, and the symbol is kg. Okay, not grams, but kilograms. Okay, so for example, if we have, for example, a mass of, let's say, 500 grams. Okay, so the 500 grams, is going to be a half kilogram, right? So a half kilogram, this is basically the value or the number that I need to use in the problem, because we don't deal with grams in physics. In 99% of the formulas, we use only kilograms in the SI system. Third one, time. The time is in second. Here I'm not aiming, to define, because all the standard definitions, are in textbooks. So I'm not aiming here to define all the definitions and going through the evolution of the definitions until the modern definition today. But I just want to give you some idea, a quick overview of the 7 fundamental units and their, symbols. So the time in seconds, and the symbol of second is small s. Okay. My preference usually, just to make it more clear in the problem, sometimes I just put SEC, like second, just to make it very clear. But of course, feel free. I mean, the ideal, or I mean, the standard symbol is just S, but this is just my personal preference, right? So for example, if the time is given in minutes, for example, let's say 2 minutes, right? So 2 minutes. Now 2 minutes is not an SI system, so I need to convert from minute into seconds, and obviously 1 minute is 60 seconds. So basically, you will multiply by 60. So you get 120 seconds, and so on. Okay. So the third quantity is time, unit is second. Fourth quantity is the thermodynamic temperature. Thermodynamic temperature, or let's say temperature, right? So the unit in SI system of temperature is degree Kelvin, and the symbol is degree K. And another common unit is, let's say, Celsius, degree Celsius. So in order to convert from degree Celsius into degree Kelvin, you add 273.15, you get Kelvin. So for example, if I say, okay, what is the boiling point of water? So the boiling point of water at normal temperature is 100 degrees Celsius, right? But in SI system, it's going to be 100 plus 273.15. I mean, here again, in IB, 273 is good enough. I'm just, trying to give you as accurate as possible information, but in IB, in application, it's fine. You just use 273. That's fine. So the 100 plus 273, so it's going to be 373 degree Kelvin. This is the boiling point of water. What is the freezing point of water? Let's say 0 degrees Celsius. So the freezing point is 0 degrees Celsius, but again, this is not an SI system. So what you're gonna do, you're gonna add 273 to the 0, so to 273 degree Kelvin, and we call this absolute temperature. So the word absolute temperature is equivalent to the temperature in degree Kelvin. Okay. So when I say, for example, the 0 absolute, so the 0 absolute, which means the 0 Kelvin. Oh yeah, so the 0 Kelvin is equivalent to negative 273 degrees Celsius. Let's say 0.15 is fine. So negative 273 degrees Celsius. This is called the absolute 0. Okay, so far we talk about length in meters, mass in kilograms, time in seconds, thermodynamic temperature in degree Kelvin. Next, quantity or amount of substance, quantity of matter or amount of substance. So fifth, I mean, the order is not, actually there is no order here. I mean, I just, random order here. So anyway, so amount of substance, the unit is mole. So the unit itself is called mole and is written MOLE. So this is the name of the unit. However, the symbol of the unit is mole, MOL. Okay. So what is a mole? A mole is a quantity of substance in a system that has as many elementary particles as 12 grams of carbon-12 isotope. So what is the idea? This is a standard. So carbon-12 isotope is basically the most abundant isotope of carbon in nature. And if we get 12 grams of that carbon-12, okay, and somehow we count how many atoms in these 12 grams, you will find this number here up, so 6.02 times 10 to the power of 23 atoms, which is Avogadro's number. So that this quantity is 1 mole. Okay. So, but when I say as elementary particles, so okay, elementary particles could be atoms, molecules, or ions. So it depends on the chemical element or the chemical compound that we are looking at. So this is the amount of substance in moles. Now, electric current intensity is the next one. Okay, electric current intensity. It is measured in ampere, and the symbol is big A. Okay, so big A, 1 ampere. Ampere is a fundamental. If you look at, let's say, the definition of electric current intensity, let's say I is equal to, let's say, delta Q over delta T. Now, Q here or delta Q is the change of the quantity of charge. So Q here is the quantity of charge in coulombs. And delta T is the time of change. I mean, the time of that change in second, of course, in SI system, right? So now we can say, okay, so now what is the unit of I from the formula is going to be the unit of the numerator divided by the unit of the denominator, right? So it's going to be a coulomb second minus 1, right? And coulomb second minus 1, we call it ampere. Okay, so this is 1 ampere. So 1 ampere is 1 coulomb second minus 1. 1 ampere is an SI system unit. However, coulomb is not an SI unit. This could be a common mistake. The coulomb is not an SI system, but ampere is a fundamental unit. Okay. Now the seventh quantity is here just for completeness. We are not going to use it at all in the IB program. Either SL or high level doesn't. I mean, we don't use it at all. It's just here for completeness. It's called the luminous intensity. And the unit here is candela or CD. The unit, the symbol is CD, and unit is candela or candela. And in the program, in topic 8 and astrophysics as option D, we're going to touch on the luminosity, which is different than luminous intensity. Luminosity is something different. I'm going to talk later in later videos when I discuss topic 8 formula. But luminous intensity is candela, luminosity is power of radiation. I will talk about this later. But again, here is just for completeness. So this basically, the 7 fundamental physical quantities or system international d'unité. Now, the last slide here, I decided to add 2 supplementary SI units as well. That will you will see them actually. You will see one of them actually, not 2 of them. You will see one of them in the program, which is the radian. Okay, and the radian RAD. The symbol is RAD, and by definition, the radian is the central angle subtended by an arc of a circle having the same length as the radius. So basically, the length of this arc here is equal to the length of that radius. So this is basically the definition of radian. I believe it's about 57 degrees, if you like. Okay, so this is the one that you're gonna meet for sure in circular motion and other topics. But then the second one, just for completeness, is called the steradian, which is basically the same idea but in 3 dimensions. So the steradian is SR, the 3-dimensional equivalent of the radian. Okay, so yeah, thanks for listening, and be happy to receive any comments on about the video. I hope you enjoyed and have a nice day.